Welcome back to Guidancee Education channel. In this video, we are going to do a numerical on refraction. Let us read the question. Refractive index of glass and water are 3/2 and 4/3 respectively. Calculate the refractive index of glass with reference to water. Identify the rarer and denser medium. Draw a diagram to show refraction of a ray entering rarer medium. Write the expression for lateral shift. How are angles of incidence, refraction, refractive indices of denser and rarer media related? The question consists of 5 sections. We will answer them one by one. But before that, please watch the video completely so that you get all points cleared. And if you find the video is useful, like the video and share it with your friends who may also be benefited. Do subscribe to my channel and also press the bell button so that you get informed as soon as videos are posted. Leave your comments in the comment box below. Thank you. Let us try doing the first section. Calculate the refractive index of glass with reference to water. What are the quantities that are given? You are given the refractive index of glass as 3/2 and that of water as 4/3. They have used the word here respectively. So these values are in the same order as the names of these media are given. So refractive index means absolute refractive index. So you have to calculate the refractive index of glass with reference to water from the absolute refractive index of glass and water. Refractive index of glass is 3/2. That of water is 4/3. So refractive index of glass with reference to water be equal to 3/2 divided by 4/3, which will become multiplied by 3/4. So you will get 9/8. So the refractive index of glass with reference to water is 9/8. So this is the answer for the first section. Let us do the second question. Identify the rarer and denser medium. Refractive index of glass is 3/2. That means it is 1.5. Refractive index of water is 4/3, which is equal to 1.33. So refractive index of glass is greater than refractive index of water. A denser medium has greater refractive index than rarer medium. So from this we can conclude glass is denser medium and water is the rarer medium. So second question is done. What is the third question? You have to draw a diagram to show refraction of a ray entering rarer medium. So it is traveling in the denser medium and then entering the rarer medium. This is the interface. This is glass, denser medium. This is water, the rarer medium. This is the normal. Just draw a ray traveling in the denser medium. If it did not get refracted, it would have passed along this line. But here the medium is changing, so it is getting refracted, and by the principle of refraction, since it is entering a rarer medium from a denser medium, it gets deviated away from the normal. So this is angle of refraction and this is angle of incidence. This one is angle of incidence. So we find here in the denser medium, the angle of incidence is less. In the rarer medium, angle of refraction is more. So that much about the third question. What does the fourth question ask? The fourth question asks us to write the expression for lateral shift. We have derived an expression for lateral shift with reference to glass slab in the previous video. What was the formula that we got? That is delta x is equal to thickness T of the glass slab by cos R. R is the angle of refraction into sin I minus R. What does section 5 ask? We have to find the relation between angle of incidence, angle of refraction, refractive indices of denser and rarer medium. Let us take the example of the diagram that we drew for the sake of answering the third question. Here you find that in the denser medium, the angle of incidence small. In the rarer medium, angle of refraction is large. Now consider this diagram in the other way. Let us suppose the ray is entering from water, that is rarer medium, to glass, that is denser medium. Then the same path will be reversed. So in this case, this angle will become angle of incidence in the rarer medium, that is large. When it enters the denser medium, by principle of refraction, it will bend towards the normal. So this will be angle of refraction. Angle of refraction in the denser medium becomes small. So we can sum up, in the denser medium, the angle of incidence and angle of refraction will be small as compared to the angle of incidence and angle of refraction in the rarer medium. What about refractive indices? The denser medium has greater refractive index than the rarer medium. ND stands for refractive index of denser medium and NR stands for refractive index of rarer medium. So for a denser medium, the angle of incidence and angle of refraction will be smaller when compared to the angle of incidence and angle of refraction for rarer medium. I hope you were able to understand. We will meet in the next video with the next topic. Thank you.